So the last thing that we did was the diagonal thing. So now we're going to talk about a specific type of polygon for just a little bit, and then we'll talk about a couple other things. So let's talk about this one first. Okay, and this would be a triangle. This is what we're doing right here. So let's discuss a triangle. We're going to learn how to label it, how to do a bunch of stuff with it. All right, we've started. I'm hearing a lot of talking. Giving you plenty of time to get ready for this. Logan, you had like 15 minutes to be ready, and you're still not ready. All right, here we go. We need to name this triangle. We've named a lot of things. We've named lines. We've named line segments. We've named rays. What else have we named? Polygons. We named a polygon yesterday, right? But on this one, what we do, if you're going to name a polygon, there's no like symbol for it, except for this one. Okay, this, you do have a symbol for a triangle. And what do you think it looks like, the symbol? Yeah, good guess. All right, so it looks like a triangle. It looks just like that. So if I was going to name this triangle, it doesn't matter what letter you start with. Just use the 3 points that are in a triangle. It doesn't make any difference at all. I'll go ABC just to keep it in alphabetical order, but it doesn't have to be in alphabetical order. Name it any 3 points that are given right here. What do we call these points where the line segments come together? What do we call that word? It's the vertex. Very good. All right, so we've talked about that on an angle. We talked about it on a polygon. This is a polygon, right? So that's going to be the vertex. What about these things right here, these line segments? What do we call those?
Sides.
Call them the sides, right? So they are line segments. So if I asked you to name the polygon or name the triangle, you would just call it triangle ABC. You could also call it, what, ACB, BAC, BCA, CBA, whatever, in any order. It doesn't make any difference what order you put those three. But you put the little triangle symbol in front of it, and that means triangle ABC. Now, here's something. Since we're talking about sides and all that kind of thing, what if I asked you, let's go to a different color. What if I asked you, what is the angle that is opposite side AC? You could probably look at this and just figure it out just by me asking the question. What is the angle that is opposite side AC?
AB.
The angle. You don't name an angle with 2 letters.
Angle B.
Yeah, just call it angle B. You could call it angle ABC, but the easiest way to call it, so if this is angle AC, side AC right here, here's side AC, what angle is opposite? So that means it's the one directly across from it. Everybody see that?
Mm-hmm.
All right, so angle B would be opposite side AC, or line segment AC. Everybody with me? All right, let's do the other two. What would be, what side would be opposite angle A?
BC.
BC, right, because here's A. Which one's opposite? The one directly across from it, okay? So BC would be opposite angle A. Everybody with me?
Yeah.
All right, got one more left. What do you think that is?
AB.
Yeah, so what angle is opposite AB?
C.
Angle C. Or what side is opposite angle C?
AB.
AB. Everybody got it?
Yeah.
So you can go vice versa. It doesn't matter. If I say what angle is opposite side BC, you would say angle A, and so forth. I mean, it's not that hard, but we will use that later on. Okay, a lot of times later on throughout the whole entire year. How many times have I said that? Said it a whole bunch, haven't I?
Mm.
That's what chapter 1 is. It's it's groundwork. Okay, it's a foundation for what we're going to do later in the year. All right, all this stuff we're going to talk about it. And we're going to talk about an angle that's opposite a side or a side that's opposite an angle in other chapters. So we need to know what all that stuff means. All right, so that I think it's pretty important. All right, let's talk about another word. It's not specific to a triangle, but it's a word that we are going to use quite a bit. I'll tell you what, let's just scooch this up because we don't really even need that right there. It's the word perimeter. You've probably heard that word before. Okay. So if I let's do this polygon. Let's see how many sides that has. That has 6. Yeah, let's just use that. All right. So I've got a nice polygon right here. This is a regular polygon. It doesn't have to be a regular polygon, but let's say it is. All right. If I said the length of one of the sides was 5, and let's say I told you it was a regular polygon. What does that mean if it's a regular polygon? All the sides are equal and all the angles are equal. So what word do we use when we say all the sides are equal?
Equilateral.
Equilateral. Good. What word do we use when we say all the angles are equal? Equiangular. Very good. Okay. And when both of those are true, it's a what kind of polygon? It's a regular polygon. All right. So I haven't even told you what perimeter is, but I have a feeling that you know what that means.
Just all the sides added up.
All the sides added up. Okay. It's the distance around. That's what I like to say. They have a little bit of a fancier. Well, it's really not much of a fancier definition. It's just the distance around a closed figure. All right. But I just shorten and I just say it's the distance around. So the perimeter of something is the distance around that particular object. Okay? A closed figure. Doesn't have to have straight sides. It could be curved. All right, but we can find the distance around something, the perimeter. So what if I asked you to find the perimeter of this?
You just do 5 times 6.
That's what I would do. I would just go 5 times 6. Where'd the 6 come from? 6 sides. That's right. 1, 2, 3, 4, 5, 6. So 6 sides. Each side is 5 if it's a regular. They're not all regular polygons, but this one is. Okay, and this is pretty easy. So if I give you one side, just one side, you should be able to tell me the distance around the whole entire thing, and it would be 30. So what if I said it's 5 centimeters? Then the perimeter is what? 30 centimeters. Okay, it's not squared, it's not cubed, it's just centimeters, just a distance around. We measure a distance around something by just using that distance. Okay, whether it's in centimeters, inches, feet, miles, whatever we use, meters. Okay, it could be any of those things. All right, that's pretty easy, isn't it?
Yeah.
They give you a little formula for that, but I don't even think I wouldn't even worry about having a formula. Now, what if it was not regular? Let's do another one. Let's keep it let's keep it 6 sides. Why is it doing that? Let's just do it. There we go. All right, let's make it like this, and let's be a little weird with this, like that. All right.
But still 6 sides.
Still 6 sides, but let's say this is 3, and let's say this is 3. I don't know. What do you think that is? Maybe 7? 7. That's probably the same.
Yeah.
It might not be. Depends on how you draw it. But let's say we had something like that, and I asked you to find the perimeter of this object. Would you just go like 3 times 6 like you did before?
No.
Would you go 3 times 7? No. What would you do?
3 times 2 plus 7 times 2.
Yeah, just add them up, right? Okay. Now, Tristan said we could go 3 times 2. Okay. Or you could just add them up. You could just go what? 3.
Plus 7.
Let's do the ones that are the same first, and then how many 7s are there?
4.
4. So you could do this, but like Tristan said, you could do this. You could go. There's 2 3s, right? Oops. There's 2 3s plus how many 7s are there? Why did I put a 4 right here? That's a 7. That was weird. All right. What do I have here? 4 what?
7
Times 7. 4 7. So you could do it that way as well. It doesn't make any difference. You still get the same answer. What's that? 6 plus what's that? 28. And that's what? 34. And let's say they're all in inches, then this would be 34 inches. All right. Pretty easy, isn't it? Perimeter? Yeah, perimeter is just the distance around something. Later on in the book, we're going to do a lot more with perimeter, and it's going to be a little more complicated. But right now, this is just the basics, just the foundation. That's all we're doing, just laying a foundation. All right, so there you go. All right, let's see what else we got. Let's do a couple. You know what? They give you a couple examples. I'm not even going to do them because what I did was good enough for the example. So let's do a couple other words. Some more vocab. Seems like this whole chapter has been just vocab, hasn't it? Like we just learn a bunch of new words, all right? And that's it. I told you at the very... I told you at the beginning of the year that this first chapter is predominantly a lot of just definitions. all right, and a lot of vocab, because we need to be able to speak the same language. Because again, later on in the book, we're going to be saying a lot of words, all right, things that we learned in chapter 1, and we're going to be using it in we're skipping chapter 2. I was going to say chapter 2, but we're skipping chapter 2. Anyway, in chapter 3, 4, 5, 6, 7, 8, and on, we're going to be using a lot of these words the rest of the year. Okay, not every single day, but we are. Did we do circle yesterday at all?
Yes, we did.
Did we? And did we talk about the radius, diameter? We did chord, right?
Yeah.
Okay. So we got a little bit ahead of ourselves, but that's okay. There's a couple words that we did not talk about. All right, so let's do that. First of all, let's draw a circle. So I go to here, and there's a nice circle. And we'll move it over here off to the side.
I like that color.
Yeah, it is a nice color. I like that one.
It's got pink.
It's like a pink color. All right. So we talked about a chord already. So I'm not even gonna rehash that. Okay. We talked about diameter, right? What does the diameter do? It's basically a chord that does what? Goes through the center, right? It goes through the center. Okay. What does the radius do? It starts where? At the center. It goes anywhere. Does it go outside the circle? It doesn't go in the circle. It doesn't go outside the circle. It goes on the circle, right? From a point, okay, so if you go from the center of the circle, that's not considered on the circle. Okay, we're not talking about like a pizza dish where it's a circle, right, and you touch the dish inside there. That's not on the circle. On the circle is like right here, this edge, that pink. That's on the circle. So where is the center? Is the center on the circle?
No,
It's in the circle, okay? So you got inside the circle or the interior of the circle. Then you got what? Outside or the exterior of the circle, okay? And then you got right on the pink. Where would the pink be? On. That's on the circle. So radius goes from the center to a point on the circle. Everybody with me? All right, we've discussed those already. Let's discuss something that we haven't talked about yet. What if I had a point right here and a point right here, and I connected those 2 points, but I connected those 2 points along the circle? You with me? I'm not making a straight line connection. I'm connecting it along the circle. So watch. If I go from here and I go along, if I can trace it along the circle, hands a little shaky. There you go. That's good enough. All right. So if you go, question? Is it a what? You're whispering. I can't hear you. An arc. Very good. Yes, that's exactly what it is. So this yellow one right here is considered to be an arc. All right. So if you go from one point to another along the circle, if you go along the circle, we consider that to be an arc. All right. We're going to do, again, it feels like I repeat myself all the time, but I just feel the need to say it. We're going to be doing a lot more with arcs later on. This is just an introduction. We're just saying what it is, and that's it. I will do this, though. Let's label it. So if this point right here and you got a point right here, we'll just call it AB, make it easy. All right. We call this arc AB, and we actually have a what's the word? We have like a notation for it. We have like a little picture for it, just like we had for triangle, just like we have for line and ray and all these other things, line segment. We have one for an arc. So what we do is we call it AB, right? And you could call it BA, doesn't make any difference. But then here's the symbol for an arc. You just put a little arc over top of it. That thing right there means arc AB. Now, we're not going to do this today, but we do measure arcs in degrees, just like we do with angles, right? We do measure an arc in degrees. We're not going to get into this today, but I'll just give you a sneak preview of what we'll be doing in another chapter. I can't remember what chapter. It's some other chapter. But anyway, if I connect from the center to this point, I connect the center to this point, this is an angle, isn't it? Are we listening? This is an angle right here, okay, that's made with that center. The center is the vertex of that angle. We're going to learn later on that there's a relationship between this angle. We call it the central angle because it makes an angle at the center of the circle. This is the central angle, and this is the arc. We say it's the arc, or how do we say it? It's the angle that cuts off that arc right there, okay? Anyway, we're going to find out that this angle is the same number of degrees as that arc. So if this looks like a little less than 90, doesn't it?
Yeah.
It's like 90 would go up to about right here. Excuse me. So if this was like, I don't know, 80 degrees, let's say, then this arc would be 80 degrees. You with me?
Mhm.
So we measure arcs with degrees. And there's a relationship between the arc and the central angle. They're actually equal to each other. So if this angle C right here was 80 degrees, then you could say that arc AB is what?
80 degrees.
80 degrees. Okay? All right. We'll save that for later, though. Let's, yeah, we're going to do that right now. All right. What if we had that circle and we took that arc and we traveled from one of the points, it doesn't matter, anywhere on the circle, but we traveled all the way around the circle until you get back to that starting point again. Okay, that's a certain distance. Okay, and that distance, come on, you need face front. You should be taking notes. You're not taking any notes. You weren't when I was looking at you. So look, the whole distance around the circle, what word did we just use a few minutes back where we talked about the distance around something? That was the what? That was a perimeter. But the circle's kind of special, doesn't have any straight lines or anything. So instead of calling it the perimeter of the circle, we could. That'd be all right. But they give it a special name. And we've already said it. What is it? It's the circumference. All right, so the circumference of a circle is basically just the perimeter of that circle. It's the distance around that circle. That's what the circumference is. Only on circles, right? It's you only use circumference when you talk about a circle. Okay, the circumference of a circle. And we actually have a little formula for this. Anybody remember? Circumference equals. It's not distance. It does start with a D, but it's not distance. A diameter times what? Nope. Nobody knows?
What's the other one? I got this. Degree? No, Matthew. We haven't talked about degree once.
Nope.
Wait, what was the question?
What's the formula for circumference of a circle? Somebody said is diameter
Times vertex.
times something. Times the vertex times the circumference. We're trying to find the circumference. The circumference is not the area.
Radius.
There's a number.
Yeah, point.
There's a number that's a constant number
360. Oh, times
That-
times the
that
arc.
doesn't repeat, but it keeps on going. The decimal keeps on going forever and ever. It's pi. Very good.
Dude, I got that.
Okay, so
it's
it's pi times what? The diameter. Now, we talked about the diameter yesterday. Let's listen now. We talked about the diameter yesterday. We said there's a relationship between the diameter and something else. The diameter is how much of something else. We talked about this yesterday. We might have not written it down exactly like this, but we talked about it.
Oh, the radius.
That's it. But it's what if the radius is... Oops, what am I doing?
The other half.
See if I can grab this. Nope, that's not it. Somebody said it. They said what? Double?
Yeah, I see.
Yeah.
The other half.
There we go. That's what I wanted. Okay, watch. See what I did? I took that radius right there and I stretched it all the way across. So what is... Shh. Hush. Just let me teach, please. Navaya, face front. Still not facing the front. Put your legs in front. All right. So look, here's the diameter. We talked about this yesterday. And from the center to here is the radius. So the diameter is how much of the radius?
Half. 60.
The diameter is half the radius?
Times 2.
Right, times 2.
Double.
So give me a little formula. Uh-oh. My pen just quit working.
2 times...
Why does it do this? Oh, I think the only way to get this to work is to restart it. And now I got to restart my video.
You do like the arc times 2?
Oh, word. It's not working. Why isn't this working? Why does it do that? I didn't like touch anything. problem is, if I unplug this and put it back again, then
Who's laughing back there?
let's see if that works. But then it's going to act weird. It's when I write, it's going to do weird stuff, I think. Anyway, let's see if it works. Yep, see, it's trying to do a 2, and it's I don't know why it does that. See, the only way I can fix this,
Is if you write back.
I think I have to. I think I might have to restart the whole computer.
Yeah.
It doesn't. See, it's not allowing me. It does straight lines, but it doesn't do curve now. That's so weird. I don't know why. Anyway, let's just talk through it, okay? So the diameter is how much of this?
Double.
Of the radius? It's double the radius. So what would my formula be? Taylor, please. Got hard enough time. Come on.
Equals 2 times R.
2 times R, right. D equals 2R, all right? So I could rewrite this. Instead of pi times D. How could I write it?
3.14.
Let's see if I can
It's
see if I can write this. Here, give
3.1459.
me a second. We'll talk about that. Okay, so circumference equals. Wow, that's really thick. Let me. Let's make this a little bit bigger than that. Why is there like a line around it? Don't know why there's a line around it. That's weird. Oh, nothing's working right. Anyway, and I don't even know how to write pi. I'll just put pi. Is that right?
Yeah.
So pi times the what? Diameter. Well, let's do this. We already got c equals pi times the diameter.
Yeah.
But if I write it in terms of what would I write? 2. Yeah, we do write 2r because 2r would be the diameter, but this is how we do it. We write 2 times pi times r. All right? So let me put an x in there for times. I know it's really weird. It's in that the font's looking crazy. That's the only thing I can do now. I can't write on this, so I'll just leave it like this. So the circumference is equal to 2 times pi times the radius. Or if you write it, you don't put that x there. I'm only doing it because I'm typing. All right, it's just 2 pi r. Okay, that's how you should write it. Circumference equals 2 pi r. So when do you use this one, and when do you use this one?
When you're finding the radius, you use this one?
Well, okay, if you want to find the radius, you would use this one. If you want to find the diameter, use this one. Or if they tell you the radius, right, you would use this formula. And if they tell you the diameter, you would just use this one. Everybody see that?
Mm-hmm.
Okay, so that's what we've got there. All right, so now let's see. We've got an example.
I need to write that down real quick.
Let me see if I can write a circle. Okay, let's see if I can make a circle. All right, at least it allows me to make a circle. If it allows me to move it over. See, it's doing some weird stuff. Don't know why. That's it. Moved it over a little bit. All right, here's a circle. And let's say you write it down because, again, I'm having issues here. I think I might be able to do this. All right, it's allowing me to do that at least. All right, so let's say the now, if I just told you the radius, it'd be super easy, right? You just, if I said the radius was 5, what would the circumference of this be? The distance around the outside. If the radius is 5, no, it's not 5 times pi times what?
2 times pi times 5.
Okay, well, what's the 2 times 5?
10.
So it's 10 what? 10 pi. That's right. Now, listen, we're going to use 3.14 for pi. I'm going to explain pi in a second, okay? We're going to use 3.14. You can do, I picked this particular number because it's easy to do in our head. So what is 10 times pi? Do it in your head.
31.4.
31.4, that's right. Okay, pretty easy, right? Just move the decimal place one place, right, to the right. So it'd be 31.4. So the circumference, if the radius was, what did I say, 5, let me do this. Let's see if I can type again. It's going to look weird again, but, oh, why does it do this? I don't know. I need to stop complaining. Just, come on. It's not going to write like that. There we go. Okay. And so, if the circumference, I'm sorry, the radius, right? The radius is equal to 5, then what is the circumference? Let's do this. Let's push this over here. So that means the circumference is going to equal 31.4. Let's make that little box bigger. There we go. Don't know why it's outlined like this, but that's okay. It works.
Oh, it's because you changed the font. I think.
Yeah, but I don't have an outline font. This should just be... Oh, maybe it's because the stroke. Maybe I have this... Maybe if I take that to 0. Let me just see if this works.
Oh.
No. All right, we'll just keep it like this. It's no big deal. It's fine. All right. So what I want you to do, let's talk about pi for a second. When's this class?
50. Yeah.
50. Okay. So, listen, I figured it out. Stop. So, let's talk about pi. I wish I could write this thing down, but it's just not writing. Why in the world is pi 3.14? Where did they get that? Did somebody just sit around and just make that number up? Amy, what do you think? It is. There's a whole bunch of numbers after it. So it's not just 3.14. It's actually 3.14159, blah, 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 blah. That's all I know. Okay? Shh, I'm still talking. I'm still talking. I'll let you talk if I ask you a question. Let me talk. So the actual number is 3.14159, and then it keeps going forever and ever and ever. It never stops. It never repeats. There's actually a couple times in there where you might see a couple numbers repeat. There might be a couple 5s next to each other, but then after that, then there's another number and another number and another number. We don't care how far it goes. I had a kid years ago. At least he told me, he had pi memorized to 100 decimal places. I'm like, okay, let's hear it. And he did. He went 3.159, and on and on. I didn't have any way to check it. That was back then before we had computers and I could Google it. I didn't have a chart or anything like that. I eventually got a little poster for my room, and it had pi up to maybe 50 or 60 decimal places. And it didn't go quite all the way around the room, but it probably went at least halfway around the room. Not this room, it was my other school. But at the very end of it, it had ... Oh, there's my flag. Why would it say ... at the very end of it?
To continue.
Okay.
Etc.
So it continues. It keeps on going forever and ever and ever. We call that an irrational number. We won't worry about that too much today. But where did they get that number, 3.14? It's actually in the Bible, too. Did you know that? Kind of.
I know
It's
that,
kind of.
It's that pi is equal to the factor of, I think it's like 22 over 7.
Yeah, but it's not exactly 22 over 7. Who's got a calculator? Anybody?
I do.
I got one. I'll put it in mine.
Oh,
So I got a button on my calculator. It's a pi button. All right. So I'm going to, if I can find, there it is. So if I hit pi, I get 3.14159. That's what I have memorized. And then the calculator. Guys, I'm trying to talk. Stop talking while I'm trying to talk. It's so irritating. I lose my concentration. I want you to stop talking while I'm talking. I shouldn't have to stop and say that. I've said it already. I've asked you to stop talking like 5 times already. Let me try this again. I told somebody yesterday, it would be so nice to just be able to teach. All right? Listen to my recordings. Like every 5 minutes, I'm like, so-and-so, turn around. Pay attention. Quit talking. Da, da, da. It'd be so nice if I could just stand up here and just teach you guys. It'd be so nice. Anyway, let's try this again. Pi on my calculator is 3.14159.2654, and it keeps going and going and going, okay? So remember that number, 3.14159. Everybody remember that? Okay, now what I'm going to do is I'm going to put 22 over 7. And it's a number that, like elementary teachers, middle school teachers will give you as another value for pi, but it's really not exactly pi. All right. So it's 3.14, but what was the next number on the pi in the calculator? It was 159, right? This one is 3.14, but it's 285. So is it the same as pi? No, but it's really close. All right. It does come out to 3.14, and there's a 2 after it, so it actually rounds to the 3.14. It's really close to pi, but it's not exactly pi. It's just a fraction approximation. Okay, so that's what they do. But when you get older into higher level maths, you don't use 22/7 anymore. Okay, you just did that in elementary school. I don't know. Do they teach pi in elementary school? At least in middle school. Yeah, in middle school they probably teach a pi. All right. What pi is though is this. What's our formula? Man, I wish I could write on this. Let me just try one thing. I wonder if I close the program. It's still recording. No, it's probably went blank on the recording. But let me just see if I can open the program again, and let's see if it actually works now. I have a feeling I just have to restart the whole computer. But let's give this a shot. Yeah, I don't think that's going to work. Yeah, it still didn't make it work. Let me just unplug this, plug it back in. Who knows? Sometimes that makes it work. Kind of doubt it. Yeah. I don't know. It might have worked. Maybe not. No, it's not. It's just, I think I have a bad connection on this cord right here, and sometimes when I bump it, it like shuts it off, and when it shuts off and comes back on again, then you can't write anymore. Let's see. See, this doesn't even. No, it didn't work. Anyway, forget the recording. Let's just use the board. Because I really want to show you where pi comes from. So we hit one of these lights. Trust me. All right. So, well, let me turn this off. All right. So let's take a look. All right, there's your formula. Circumference equals pi times diameter, okay? So what if I wanted to actually solve for pi? What's the algebra here when I want to solve for pi? Okay? What's the algebra? If I want to get pi by itself, what do we do? Algebra 1. You had algebra 1 last year. So what if that's a variable? What if it was an x? And you wanted to get x by itself? What would you get rid of? The d. How do I get rid of the d? By how? Divide. You divide, okay? So watch. I divide this side by d. Come over here and do what? Divide that side by d. So what's pi equal to? The circumference, what? Divided by the diameter. That's how you find pi. I used to have this, and I should have, I don't know, I just don't think about it until I get here. But I used to have a cardboard circle that I cut out, and I had a piece of string. And what I would do is take that string, wrap it around the circle, okay, then I'd measure the string, right? Just come out like this, have a ruler, measure the string. Then I would measure the diameter of the circle. Wait a minute, no. Then I would measure the diameter of the circle. And guess what I would get? When I took the circumference of that circle, and I said don't pack up yet. We'll stay here. If I took the circumference of that circle, divided it by the diameter of that circle, what do you think I came up with? Which is what number? 3.14. Now, I didn't come out exactly 3.14 because, just wrapping a string around is not very accurate. The measuring is not that accurate. But I always got a little bit more than 3. All right? That's what pi is. Pi is the circumference divided by the diameter, and you'll get it every time. It doesn't matter if your circle is really small, right? Because it's going to have a smaller circumference and a smaller diameter. If your circle is really big, it's got a big circumference and a big diameter. It doesn't matter. The circumference is always a little bit more than 3. So if you walk around a circle and you compare that to walking straight across, you're going to walk a little bit more than 3 times that diameter. Does that make sense for pi? Okay. All right. You have a homework from last night. finish that. You got homework for tonight. It's on that lesson plan thing I gave you yesterday. So get that done, and I'll go over those and collect those tomorrow.
Thank you.